Okay, we're at the St. Mary's parking lot in Chelmsford, and today we're going to be talking about the golden ratio. And Frosty's coming with me today. We've been getting quite a bit of snow in Chelmsford, and you can see it's piled up just about everywhere. And now we're going to go inside the church. Okay, we're looking at the Holy Family. There's Jesus, Mary, and Joseph. Now, what we want to look at here is difficult to see because of the light, but you can see what is Joseph holding in his hand. It's a carpenter square. It's a right angle, and that's why we came to look at it. Okay, here we are back at our man Drive, and there's also another statue of Joseph right there, Joseph and Mary and the baby Jesus. They left Bethlehem after the visit of the three wise men, and they began heading south. They fortunately were captured in a snowstorm, and they really haven't been able to move now for several weeks. And you get an idea how deep the snow is now. It's pretty deep. Let's go inside. Okay, here's a carpenter square, just very similar to the one that Joseph was holding. And this is a right angle, and you can see that when they made this, they tried to put these pins in so that this wouldn't move, to try to keep it so it's always 90 degrees. And today I wanted to talk about the golden ratio. And what does a carpenter square have to do with the golden ratio? Well, the reason is because the golden ratio actually started out of geometry. And it started so long ago that we don't really have any written record of the first person who came up with that ratio. The guy that really we do have some written story about is Pythagoras, and that was about 500 or 600 BC, long time ago. And he was interested in geometry, and he came up with the golden ratio. But it's going to take a while. First, I want to. Along the way, he came up also with this right angle, which is also related to geometry. So you might ask, how do you make one of these if you didn't already have one to measure it? This is just for measuring things to see if they're square. But before they had those, they had to do geometry, which is to say they had to build things without squares, and one of the first things they used was rope. Rope, if you have 2 points and you want to make a straight line between them, a piece of rope works just fine. Or if you have a point and you wanted to make a circle, you wanted to see that if two things were at the same distance, you could use the rope. You could measure the distance between here and here, and then you could use it to measure there and there. And you'd be able to use the rope as a measure. Nowadays, what we use for a measure is a ruler. The ruler's got a straight edge on it, but it's all marked off. That's just like a rope if you had put little marks on the rope to see what they were. That straight edge is a lot easier once you have it. But before you make it, it's hard to make it. You need tools to make it. Before you have tools, you probably could get a rope, because you find rope hanging out of trees and stuff like that. Another thing that we have, aside from to measure if two things are the same, is something called a compass. You can you can measure how far it is from two spots. Then you can lift it up and you can see whether or not two other spots are the same distance. Or you can put one down and you can mark out a circle to get all the points that are that distance. This one, all it has is 2 points. this won't actually draw a circle unless you dig it in. But nowadays, you could do that with the rope, but you could also do that with a compass that has a piece of a pencil on it, and you could draw a circle, and that's for measuring the distance, and this is for giving you a straight edge. Although this one is already measured off, I'm not going to use it for the actual measurements. I'm just going to use it as a straight edge, because back in the time of Pythagoras, what they tried to do was geometry using a compass and a straight edge, and that's basically saying that they were using a piece of rope and nothing else to do the geometry. Now, one of the easiest things that you can do in geometry is to say, let's say you had 2 points. You could call point A and point B. Now, in geometry, there's a book that's kind of like the Bible of geometry. It's called Euclid's Elements. Euclid wrote down a lot of the geometry theorems that Pythagoras made, and he did that around 300 BC. But his copies are the only copies that really are still left. So we don't. Pythagoras might have wrote some stuff down, but we don't really have that. And I'm going to try to show you about the golden ratio, how you use geometry. But before we do that, I want to show you some of the simpler things that you can do with geometry. One of them, and this is the very first proposition in Euclid's book of the elements, that is the elements of mathematics or geometry, because geometry was one of the major parts of mathematics at the time of the Greeks, was how can you create an equilateral triangle? That is a triangle that has 3 sides all the same, and whose one side is equal to the distance between 2 given points. Well, one thing that you can do is you can obviously connect those two. That gives you one side of the triangle. Now the other side of the triangle, you can kind of imagine it's going to look like that. Or it could look like that if I did it down here. Now, if you had to do this with a compass and a straight edge, most people can figure this out after a few minutes. Because the good thing about the compass is you can mark it off so that it's equal to the exact distance of the triangle you're trying. Having marked it off, you could then try to use this to find out where the other spots would go. So one way to do that is you put the compass down on one side, you draw an arc. You put it down on the other side, you draw an arc. Then you take that spot and you say that the distance between here and here is exactly the same as the distance between the first 2 points. And also the distance between here and here is the same distance as the distance between these 2 points. So you can connect those, and this is an equilateral triangle. And you constructed it basically with a piece of rope. That's pretty good. Now, the angle inside an equilateral triangle is not a right angle. The reason they call it a right angle is because that's the right angle to build with. You wouldn't want to build something that was crooked. It would fall over. And if you're putting 2 pieces of wood together, you like to have them, each one to be cut at the right angle. Then that way they'll actually go up against each other without having a gap between them. Nowadays, we also call that a 90-degree angle. But back then they didn't have degrees. They just called it the right angle. The equilateral triangle, the angle there is not a right angle. We call it 60 degrees. They could call it 2/3 of a right angle. Now, another one that they did was, now to get more to the point of making a right angle, because this equilateral triangle doesn't have a right angle, but it was easy to do, is you could say, let's make a square. Because a square has 4 sides, all the sides are equal, and all the angles are 90 degrees. That's really what the definition of a square is. Now let's say you took 2 points. you can take these 2 points and consider them to be totally random or arbitrary. And let's say you wanted to make a square whose side is equal, one side of the square is equal to that line or line segment. Okay? Well, you got your compass and your straight edge, and you say, well, gee, how can we do this? And if you work at this is a little bit more complicated than the triangle, but I don't think it's also terribly bad. It's also in Euclid's Elements. That's one of his propositions, is how to make a square. Well, one thing you want to do is, basically, you want something here at 90 degrees. Now, you know what the right distance is, right? Now, let's mark off that distance. If you want to try this, of course, you could always stop the video and try it yourself. Let's say that's the original distance. I can mark this over here, and I can mark it there. Now this is a trick. It doesn't come immediately as obvious, but if you open up the compass to a greater distance, what you can do is you can mark it above and below. Now, probably everyone watching this video probably learned this in school. This, if we connect these lines, these dots, what you find is you get a right angle there. And this is the also the way that you would bisect a line. I started off with the line, then I just got an equal distance on the other side, then I bisected it. It gave me a 90-degree angle, or a right angle. Now, once I got one right angle, pretty much, if you can find one right angle, you can do the rest, because the rest of it is not so hard, because you just work your way around. Like, I can take this spot, the original spot, mark it out, and I can mark it up here, for example. That's going to be one of the other points of my square. There's only one point on my square that's missing now. And I can get that. I could make a perpendicular using this spot, for example. Right? Then I can do the same trick I did before. Now there's more than one way to do this. I mean, in terms of looking at the exact order of the things that I do, even though you're going to come up with the same result, you could do these in a different order, but you're going to basically come up with the same result. So if now I connect these three, okay, that gives me another side to this. I still am missing the very last corner, but I can get that now if I mark this off. Okay, that gives me the last corner of the square, and then I connect that, and not only have I created a right angle, I created a square also, but the right angle was part of it. And this kind of answers the question. Let's say you were going to wanted to make a square, and you had two pieces of wood, and you're going to put them together, and then you're going to nail them together. This is a way of making the right angle to start off. Of course, you could always just make one that looked like a right angle, but most people aren't as good at that, because it's very easy to look at something and not to get it exactly right. Like, did you ever hang a picture? You thought it was level, but it's not really that level, because your eyes are not that good at measuring something as accurately as you can with this technique. So that's the square. We just did the triangle and the square now. The next thing we're going to do is the tricky part. This is what we're working up to. It's the pentagon. 3 sides, 4 sides. The pentagon has 5 sides. How to make a regular pentagon. This is something that Pythagoras and his followers, they figured out. Now, I think we'll do that on another lesson because I think that's going to run over the time on this one. Okay? So I'm going to turn this off.